RAD Studio. And first I'm going to create a new simple multi-device application. So when you create a multi-device applications in either Delphi or C++ Builder, you have a certain templates. There is one of the templates is a 3D application. If you select a 3D application, you will have the main form of your application will be a 3D derived from a T form 3D. However, I would not use this approach to create 3D applications, because the form 3D as compared to the regular 2D forms does not provide enough functionality, for example, for supporting multi-touch on mobile applications. So it is much better, I'm going to close this application without saving it, to start from a regular 2D application, for example blank application, and on top of this application, on this form, we can use a Viewport component that provides a view into a 3D space. It's typically common to align this viewport to client area so it occupies the whole screen. We can change the color of this viewport from white to black. And what I'm going to do right now, I'm going to build a simple visualization of Earth and Mars rotating in a deep space, and also demonstrating some of the key concepts of building applications in 3D. So I'm going to start with adding a T-dummy component. So T-dummy component is a useful component for grouping other objects. So it does not, when I run the application, let me save this application as a simple 3D demo, new folder, simple 3D. So I'm going to save this application. So if I okay, this is a simple 3D. So if I run this application, it will just be black. So the dummy does not provide any visual representation, but it's useful for grouping other components. So here in a 3D scene we have components, and on 3D shapes we have different components that we can put here. So if I want to visualize Mars and Earth, I'm going to add two spheres. In FireMonkey and also in FireMonkey 3D, it's very important to understand which component contains other components. So I want to make sure that my both spheres are contained directly by a dummy, and I'm going to change the name of the first component to sphere Earth and the second component to sphere Mars. Okay, and then I'm going to actually, because right now these components, they have a position 0, 0, 0, and so they just are on the very same spot. So I want to actually move them a little bit away. So I'm going to change the X property of my Earth to be something like -1, or maybe -2, or -1 will be fine. -1, and the Earth, the Mars, will be +1. So in FireMonkey 3D we have three axes. So the X direction points to the right, the Y axis points to the bottom, and Z axis points into the screen. So right now I have two spheres. So I want to actually make them look like Mars and Earth. So the next step is actually to add a material. So in the materials tab, in the object in the tool palette, we can add different types of materials. So they represent different models of shading. I could actually use a T-color material source just to give any shape a color. I could use a light material source to give it lighting, like for example Guro lighting, or I can use texture material source if I want to apply apply a certain texture to the object. So I have two objects. One is for earth, so I'm going to take this first texture material source and call it texture material source earth, and I can now load into the texture some predefined. I have here in pictures. I have downloaded earlier from internet an open source texture of earth. So now I have this texture loaded into the component. If I click on my sphere earth, there is a property called material source I can use to assign to this component. And now I need to have another texture component for Mars this time. So I'm going to do it like this, Mars, and I'm going to load another texture, this time with the image of Mars. Okay, so this is my Mars. So I have now two textures. So also need to set the material source property to be Mars. Okay, so we have now two spheres, and like I said, the dummy is a useful container. I can use dummy to, for example, change the scale so my image looks bigger. So I can, for example, make it 3 times bigger in the X direction, 3 times bigger in the Y direction, and 3 times bigger in the Z direction. Also notice that when I change the property of the dummy, all contained objects actually inherit this property. I can change also things like, for example, oh, that's maybe not a good move. I want to change the rotation angle, like for example 45. So just by adding different objects of the 3D scene to the dummy, I have just one place to manipulate the whole scene. Okay, so that's good. So I have two nice objects, but typically I would like to see some rotation. Let me add a rotation components, actually animation. So I need to have float animation. So I double click on float animation, and this float animation has been added to the sphere earth component. So if I open the property name, I see all the properties of the sphere that are of type float. In this case, I'm interested in animating rotation angle Y property. I want to make it loop, and the duration will be maybe not so fast, but maybe one second. I want to make sure that this is enabled, and also start value and stop value, I want to go from 0 to minus 360, so my earth is actually rotating in a correct direction. And let's see what we have here right now. Okay, so this is my earth is now rotating. So this is actually, I have not written any line of code, so this is exactly the same steps for Object Pascal and for C++ Builder, and I have a nice visualization of a rotating earth. What is also very interesting is that this is interactive. So if user clicks on different elements, he can actually interact with the scene. So what I'm going to do is I'm going to implement the on-click event on sphere earth. So when the user clicks, then the earth will come closer, and when he clicks again, it will go further away from the viewer. So first I'm going to change the location of the sphere earth to be somewhere closer to us. So the Z direction, the Z coordinate goes into the screen. So if I want to make it to look closer or bigger, it has to have some negative value. I'm going to add it negative value -3, and now our earth is quite close. If I make it 3, it is quite far away. So I'm going to make it -3, and I can now double click on add the on click event to sphere, and I'm going to change its location. So if my sphere earth position Z is actually smaller than 0, then I'm going to move it to the sphere 0 equals 3, and otherwise I'm going to make it to move it closer. Okay, sphere Earth minus 3. So that's a little bit of code. The code in C++ will be very similar. And now if I run the application, I have a 3D application that is also interactive. So these are some key techniques for building 3D user interfaces. And now let's have a look on something more complex. So I'm going to move to the molecule hero that I have created started to work on it back in the XE2, Delphi XE2 time frame, when the FireMonkey was introduced. And now it is implemented in the latest RAD Studio 10 Seattle. So I'm using here components like multi-view. So and also this multi-view is used as a menu for displaying different predefined chemical molecules that are actually hard-coded inside of the application. Notice here I'm also using, this is one big viewport, but I want to add certain functionality. So you can use just a regular T layout component to put traditional 2D components on the 3D screen without really taking away the space of the screen. So if you would use a toolbar, then your viewport will be smaller. You can use a layout, and then you can put things like a T label or a T speed button on the form. Let's have a look how this application works, and then we can have a look at the source code. So this is probably the most important chemical molecule in the life of a developer, caffeine. So that's something that makes us code efficiently. So I can visualize. Notice that this is again, I'm using mouse on Windows, but on Android, on iOS, I would use just a touch. And then I have a different modes of visualization. I can visualize atoms and bonds. I can just visualize atoms without bonds, or I can just visualize bonds alone. There is also functionality here to make it closer or further away. And then I can change one of the predefined molecules that are built into this application. So that's a demo application, so there is no possibility to actually visualize other molecules, but that will be relatively easy to achieve, and that's my goal for the 2016, to add a functionality to this application to visualize arbitrary 3D molecules. So here I'm using a PDB format for the protein data bank. That is actually standard format for exchanging chemical molecule information. Also here I have another form. So this is for 3D. So this is a molecule hero. So that's a nice, I hope nice artwork that is necessary for this application to be accepted on one of the Play stores. Okay, let's get out of this application. Let's have a look how this application is structured. So these so there are two main. So we have one main viewport and one dummy component. Here is a camera component. So the camera component is actually, you can see there is a camera and light, so you need to have so I have light exactly in the same place as camera. And also the viewport main has a property called camera, so I can connect camera to the viewport. And also there is a property use design camera set to false, so the viewport does not use the camera that is built into the FireMonkey framework, but the one that is placed on the